next speaker is Kris Nova from Microsoft, and her interesting fact, and this is really an interesting fact, I think, is she's preparing to climb Mount Everest? Summit Mount.
Better than mounting it. What is with you today?
That is what else would you do to a mountain except? So Kris is going to go to the top of Mount Everest in 2019.
That's amazing. Kris Nova, everybody.
How's it going? I started training for Mount Everest just recently, and it's been crazy. I'll get more into it as we get into the slides. And I got this handy dandy clicker, so I'm just going to pace the whole time. I hope that's cool. Okay, so Implicitly Impacting the Cloud with Go by me, Kris Nova. Wait, hold on. Not working. Also, I run Linux, so give me a sec. Let's see. It was working. Is it on? Yeah, it's on. Oh, there we go. Okay, I had you click on the window. Okay. So anyway, Implicitly Impacting the Cloud with Go by me. Okay, so my name is Kris Nova. Like they said, I work at Microsoft. In fact, I write Go at Microsoft, and this was kind of exciting because I really never thought I would say that or that this slide would exist. If you would have asked me if I would be saying those words a year ago, I would have laughed and been like, nah. I also use Linux at Microsoft, and I am running the entire Chrome browser and my operating system with our slides in Linux. And if I was to go lift up my computer there, you would see the Microsoft asset tag on the bottom. It's my real work computer, I promise. Also, my Wi-Fi driver usually works. I work with Kubernetes a lot. So show of hands, I do this at every talk, but show of hands, who here has used Kubernetes in production? Okay, good. I just want to know where we are, if I can go deep or not. Okay, so I work in the cloud. So when I first joined Microsoft earlier this year, I joined the Azure team as a software engineer, writing Go. Now I am advocating for Azure and all of the fabulous stuff we write with Go. More importantly, I play in the cloud, and this is a play on words because as Steve was mentioning, I climb mountains. In fact, all of these pictures here are from last week when I climbed Mount Rainier in Washington, yay. So I strategically took these pictures with the top 3/4 kind of blue or whatever, so I could put text on the slides. But this is pretty cool where we're above the clouds, and I'm like, hey, I work in the cloud and I play in the cloud. Okay, so another show of hands. Who here is an engineer? Software engineer or just regular? Oh my God, everybody literally just raised their hand. Or an engineer-minded person. So I go to a lot of talks, and I give a lot of talks, and this is my present to all engineer-minded people in the room. This is how the talk is going to go today. We have 3 work items, and we'll go through them from top to bottom. The first one is going to be me talking about the cloud, so I won't be talking about Go, even though we're at a Go conference. The second one is talking about Go, and then the third one is munging the two together and talking about how Go has impacted the cloud as we see it today. So I feel like I'm the project manager. Item 1, the cloud. Also, another super dope cloud pick. So we're going to talk business. And I'll try to keep this part short, because these are kind of what I consider the CTO, CEO slides. But the Cloud Biz, as I like to call it, it's this new thing that's kind of been happening over the past couple of years, and we're at a really exciting time right now. And I'm kind of hoping that in this talk, people will leave walking away you know what, I really am able to make this a big impact in the work I'm doing with Go in the cloud. So my one data point here is Forbes.com interviews Fortune 500 companies every year. And this year, 2007, so this year, we have grown from 19% of the same companies they interview every year running in the cloud to 57%. So 3 times roughly in this year alone. So raise your hand if you Oh, I forgot what I was going to ask. I know. Oh my god. Raise your hand if you have written anything Go related this year, like any blog or anything. Okay, so there's a good chance that these companies, these are oil and gas companies, these are Disney, Amazon, larger companies that you say around the house, have moved something to the cloud, which means they've probably read some of your Go work. So there's this foundation called the Cloud Native Computing Foundation. It's a subset of the Linux Foundation. And their entire goal is to sort of represent the cloud and talk about and advocate for these things that are moving to the cloud. And there's this whole concept called cloud native. I talk about it literally all the time, but I realize not everybody is in the cloud space like me, so I wanted to make sure you guys knew that big names like the Linux Foundation are taking this extremely seriously. So a little bit about my experience with the cloud, and this is like kind of a tip for everyone here. There's a guy, he's a friend of mine, his name's Ben, he works at Google here. He gave me a piece of advice a long time ago, which was to put the word cloud on my resume. He's like, you've done some stuff in the cloud. And literally overnight, recruiters started emailing me and calling me. And it worked, and I couldn't believe it. And he was like, I'm telling you, Kris, and this is 2011, he was like, I'm telling you, this cloud thing is going to be huge, and if you get in now, it's going to really, really pay off in the end. So for me, even adding this one word, this is a snippet that's up here for you guys, a snippet to the top of my resume, open source leadership, cloud development. If you've done anything in the cloud, get this on your resume. Okay, enough businessy things out of the way. So let's talk tech. So what really is the cloud? So implementation aside, it's really just HTTPS. That's really the only thing you and I are going to interface with 99% of the time. And that might come in the form of like clicking buttons in a portal, but it might also come in the form of like curl minus capital X or some other programmatic way of sending HTTPS requests. So everything in the cloud, like we all kind of know that like you can get a virtual machine or you can get an app or a database or heck, you can even go get like a virtual network if you want. All of that happens over this HTTP conduit. And it's an abstraction for pretty much all the things in the cloud. But what happens on the other side is pretty straightforward. It mutates infrastructure and applications. Or I guess in some cases, if you're sending a GET request, it could query them. But the point here is we're not doing anything like super duper crazy. Like we just take HTTP requests and like do stuff with them, right? So I know we have all written applications like this. If you haven't written an application like this, then you really need to get with the program because this is all we do as software engineers, especially as Go engineers. We put this API in front of some system. It can do whatever you want. And then it goes and it mutates the system, makes a change, massages some data, maybe even hits another API, and then returns to the user, and that all happens over the HTTP protocol. As software engineers, what are our expectations for these APIs? Like if you're like, you know what, I'm gonna go write some code today, and I'm gonna go consume some data from this API. There's like this like unwritten rule as software engineers that, or unwritten rules rather, that we sort of expect. And the first one is speed. We expect this to sort of happen in like a reasonable amount of time. I always think of like the first time I kind of learned about the cloud and it was like, whoa, I got a virtual machine. Like in my mind, I was like curl minus H or curl minus capital X, and then like this dude was like walking through the data center and he's like, oh dang, and he like got a page and like had to run over and like configure a virtual machine really quick and then like come back and was like, okay, we're gonna tell the server it can now like let the socket go, and then like my request would come back. But we all know that doesn't really happen. It's all virtualized now. So as a software engineer, if you send one of these HTTP requests, you have this unwritten, implicit expectation that it will return in a reasonable amount of time. Also, accuracy. So this is a big one. And if this has ever happened to you, I deeply apologize. But we need to be able to trust our APIs. So the whole HTTP protocol is this sort of like document that was like set forth by like the grand overlords of the internet with like big beards and wizard hats, not really. But it says, you know, if everything goes cool, like, yeah, tight, bro, your stuff worked, you get like a 200, or like, man, something went wrong, you get a 500. As a software engineer, it's reasonable for you to expect those codes to be accurate. If something goes wrong, you want to know about it. You never want to be in a situation where everything looks fine, but really something sinister is lurking beneath. So we have this expectation that APIs are accurate, and they're accurate a lot. So we built that. That was the cloud. Literally, the past 5 years of my career has been building this infrastructure, either for companies or for like personal side projects, or even just to like get the free GitHub points next to my name. I'm gonna go open source something, like GitHub bucks, right? Like we all want those. So anyway, to me, the metaphor here is building out the cloud has kind of been like building out this highway infrastructure. So like, we are in a situation today, like this is happening right now, where like self-driving cars are a real thing we talk about. And the only reason we got there is because at one point we had to build this. We had to build this infrastructure. So that's where we are with the cloud. We have the highway up and running, and people just in the past couple of years started taking the first cars, metaphorically, out on this highway. And it's interesting because like if you go back in the time when like real cars started driving on real roads, like things were kind of different then. Like windshield wipers was a big deal. Like the cars used to not have those, and headlights were a big deal, and seatbelts were a big deal. We kind of had to learn these lessons, right? I feel like we're there with the cloud. And as Go engineers, we're gonna get there later, we have some really cool stuff up our sleeves. Okay, so we have this infrastructure in place. The cloud happened. We have it now. You can go log into Azure. You can go log into Amazon. You can click buttons. You can get infrastructure. So what did we do? Well, we do what all good software engineers do. We automate things. Show of hands. Who here has written a Jenkins job at any point in their career? And then you get a button, and when you want Jenkins, or any CI/CD system for that matter, to do something, you can go and you click a button, and you're like, you know what? I did good today. I got a button for that now. I used to have to like actually run a shell script, and now I have a button. I'm doing really great. So that was great. And to quote a really good friend of mine, Charity Majors at Honeycomb, she said this to me. We were like at brunch or something. So I'm stealing a quote without asking her about it first. She said automation is dead, and that stuck with me because I really thought about it. Like that is a really, really powerful statement, and that's where I think we are today. So we quit automating things and we started scaling things. And they're kind of the same thing. So when you scale, you go from one number to another number. And there's some set of items. If the first number happens to be 0 and the next number happens to be 1, then you've effectively automated something. But we can take that one step further and go from 1 to 1,000,000 now, or 1,000,000 back to 1. And so that was sort of the next evolution, is like, okay, we're gonna start having these services that are scalable. And I just had a tweet about scaling. You should just ask about it. It was super hilarious. So I think about that every time I see this slide. Anyway, scaling things was good, but we're gonna go one step further. So it was yesterday on Twitter, I'm gonna pick on Jessie here. She tweeted something, I know, about making apps deploy themselves. For me, I had never thought about that. And like within seconds, I was like, whoa, I can already see the Cobra command that I'm gonna write where this app is gonna go deploy itself. And apps are going to like enter this new space of managing themselves. So this is a really great concrete example of humans re-architecting how we solve problems. Like makefiles were a reflection of us needing to automate the same build tasks. Well, we kind of don't need to just drop a binary off anymore. We kind of need to go a step further. And so we're solving these older problems in newer ways. So that's where this re-architecting is coming, and you're seeing that today. Just like the cars with windshields and just like the cars with headlights. So TLDR, also another beautiful cloud pick. The cloud is changing all the things. Because of the cloud, software is implicitly changing. Okay, now for the fun part. Here's my gaffer here. Thanks, Ashley. I love you. So anyway, we're gonna talk about Go, which is why we're all here. But anyway, it was probably nice to get a little bit of a philosophical break from Go. So why is Go awesome? I'm not gonna go super deep here. We have a ton of great talks going into super low level constructs, but I wanna demonstrate patterns as Go engineers. Number one, we can consume C libraries, which everybody's like rolling their eyes like, oh, another C Go part. And it's like, no. This is powerful because guess what you can do with C? Hint, everything. So we can do that with Go. Also these implicit interfaces. So this is a really exciting pattern. And it's really powerful. And as Go engineers, if you grew up writing Go, or even if you're just getting into Go, being able to use these implicit interfaces is a really big part of what we're doing. And it allows us, as software engineers, to abstract ourselves away from implementation and only care about utilization. And we do that at runtime. So I always, like when I talk to people about this, I always use this thought experiment. Imagine a Go file, and at the very top there's an empty struct. And it's about 10,000 lines long, and it's just littered with methods on that struct. And we have defined that file in such a way that any interface in the Go standard library could be implemented. And you could do that. And implicitly, at runtime, we have this mysterious object that could be anything in the library. It could be a writer, it could be anything. Which I think is powerful, because we can sort of like turn one thing into another, but it's not like this chore of going and changing our code. Also, we get these like super tight static binaries, which are really handy, because me, coming from a systems administrative perspective, where I used to write bash scripts, the first half of my career was like getting up from my desk, like walking over to somebody else's desk, like coming over here, what's going on? Your script doesn't work on my computer. Run your script. Damn, you're right. Okay, let me go back to my desk and figure this out. And then I would go back and I would figure it out. And it's funny, but really that's what I did for like 3 years. Go solve that problem. You can compile it into any architecture. My good friends Goose and Gorge make it so easy, and the way that the compiler works makes it even easier for us to build these static binaries. And again, there's going to be great talks here and at other Go conferences where people tell you how all that works. My point is, it works. Concurrency models. I don't need to say anything more. We've all seen the Rob Pike videos, and we all have played with channels. We know that it's powerful. This one, though, this is one of the big parts of Go I feel like always gets overlooked. So it was 2014. I'm at Galvanize in Denver. One of my friends told me there's this new programming language called Go. You should go check it out. I think you'll like it. I had never heard of it, so instantly I was like, I have to go learn everything about this programming language so I can be the smarter friend about it, because that's like the entire course of our friendship. So I went to this Go meetup, and I've been writing Python and PHP and Bash for 3 years at this point. And the guy's like up on stage, and he's like talking about compiling and errors, and I'm like, bro, like what is all this noise, man? Like, can we just write some code and run it? So I'm kind of like doubting this programming language. And he comes over to my computer and he's like, do you have your main function? And I'm like, yeah. And he's like, do you have Go installed? And I'm like, yeah. He's like, type Go run. And my program ran. Like, it's an interpreted language, but it's not. It's doing all this stuff behind the scenes, but the compiler was so fast that to me, it felt like an interpreted language, which I think is powerful. And I'm sure other people here have had similar experiences where they kind of like go from this interpreted world to this compiled world, and Go sort of makes that transition a bit cooler. Not working. Did I lose it again? Let's see. Okay, so switching to Go at Microsoft. I'm going to tell a bit of a story here, but I won't be too long, I promise. So like I mentioned earlier, I joined Microsoft. And they were like, we want you to write Go. And I'm like, okay, let's do this. So I went to Redmond for the first time. And I had never been on like a big tech campus before in my life. And actually, you know what, show of hands. Who has been to the Microsoft office in Redmond? Okay, it's a city. It's not even like an office. It is literally like an entire city. And I crunched some numbers before I came. 80,000 people commute to this thing every day. It's up in Washington. And then I was like, I wonder how much the Broncos Stadium can hold. So the Denver Broncos Stadium in Denver, where I live right now, holds 73,000 people. So if you've ever driven through Denver when the Broncos are playing, it is just impossible. I mean, you cannot go anywhere. But these people go into and out of the Microsoft office every day. So here I am, like, lost, cold, alone, gonna go write Go at Microsoft, and I'm just walking around, and every person I see, I'm like, I know you write C#, I know you write C#, I write Go, but I know you write C#. And I got to the to our office, and I walk in, and one of the managers like comes up to me, he's like, Kris, so great to see you. We just finished deploying our first Go app. And I'm like, awesome, cool. I really like this. So to hear that Microsoft is switching to Go is so, it still just kind of gives me like the chills a little bit. And anyway, that's what I started doing. I started writing Go. Okay, so we're going to look at the cloud plus Go. Okay, who runs apps in the cloud? Okay, who runs like a blog or like just like, yeah, something kind of small, easy. It probably like does HTTP, right? Who has like a lot of apps in the cloud? Like a lot, either for work or at home. Okay, how many of them run in containers? Yeah, wow, more hands went up than people who, like we have more containers that run in the cloud than apps that run in the cloud. That's awesome. So let's talk about containers. This is one of my favorite pictures ever. This is like 3 days where we did nothing but talk about containers. And if you look in the back, there's a container ship. And we're talking about Kubernetes, and it was like this moment. So I had to put this picture up here. So talking about containers, I started to explore Docker recently. And I had a little hackathon get together in San Francisco where I ported Docker to FreeBSD. Or at least I tried to. The first time somebody kind of mentioned this to me, I was like, hell no, nope, not even gonna get close to it. And then I kind of thought about it some more, and I have worked in the FreeBSD source tree. I do know its internals, and I'm always down for a good C project because that's normal for me. So I was like, yeah, sure. So this whole thing happened, and you can see if you go to the FreeBSD Wikipedia, we organized Docker Hack Day 2017. And the whole point was one of the people at the hack day had some like ongoing IRC argument about jails in Docker that we like had to solve. And how we had to do that was we had to like demonstrate Docker could run on FreeBSD so that they could run some like arbitrary test thing, and then they could finally put their like 2-year-long debate to the end. And that's how I got roped into roped. That was a mountain pun. How I got roped into porting Docker to FreeBSD. So we did that at the Microsoft office, which again, I never really thought this slide would exist. Yeah. People drove over from Berkeley, like Berkeley Software Distribution. And they came to Microsoft, and we sat down, and we like, have you guys seen the movie Shawshank Redemption when they're on the roof? And he's like, we sat on the roof with like the sun on our shoulders and drank cold beer. Like, I felt like that. Like, we were writing C in FreeBSD, drinking Diet Coke at the Microsoft office, and it was. So anyway, so what did I learn as I'm like digging through the internals of the Docker source code, trying to learn how I could get all these things up and running on FreeBSD? Docker is super hard. Like, the hardest program and the most confusing program I've worked on, plus about 10 more steps. So this, I don't know if you guys can see it. Can you see it? Probably. This is what 90% of my work looked like when we were working at this Docker project. And if you look at this big comment in the stock block at the top, probably most of my god-awful hacking is done in this file. Most of this is in place to hack around the Go standard library since we are using a Linux package in FreeBSD. And I'm like, I like apologize and I like leave my email to like, I'm so sorry that you're having to read this because I know you're like dealing with what I was dealing with. But then more importantly, you go down and it's CGO. I never realized Docker vendored so much C before. So FreeBSD was equally as hard with Go, to the point where I had to go and define these FreeBSD constants just so I could interact with the C libraries in FreeBSD that were really shims of the Linux API on top of FreeBSD. It was fun. So I had to go in and define these constants, and I'm like, I'm so sorry you're having to deal with this, but guess what? Like, we got epoll working with FreeBSD using the Linux API, and then like we got all this done, and then like, oh, we should just use KQ. And I'm like, okay, whatever. So anyway, the point here, we couldn't have done all this if Go did not have CGO, and it did not have this beautiful syscall abstraction. Like, that's kind of an important deal. We're writing C, but Go allowed us to do that. So as I'm exploring the syscall package, and like I felt kind of awesome before, like I've used syscall like once or twice, like yeah, I'm doing really awesome low-level Go stuff right now. This was like, I like became a syscall expert in like a day, because this is all I did in Docker. So anyway, I discovered it is locked down. And this is cool, this is really cool. It's locked down and we're not making changes to it, the Go standard library anymore. So if you think about it, we went through this mental exercise as a community, the Go team did, where the syscall being locked down, I'm going to just cut to the end here and then I'll rewind, is actually a reflection of we're damn good at syscall. So how that happened was the Go standard library said, okay, we're going to make a syscall abstraction package to allow people to consume syscalls. Then we did it, and now we're going to run this package. And then we're going to develop opinions about this package, and then we're going to develop feelings about those opinions, and then we're going to decide that those opinions are wrong or incorrect and we want to change them. And if you go online, there's a Google Doc, and it's loaded with all of these concerns about the syscall package. It's bloated. It's noisy. It's hard to consume. So we're already iterating on our syscall abstraction. I challenge anybody here to name another programming language where they've iterated on their syscall abstraction other than C. So thanks, Go. You allow us to do these wonderful things like vendor the unsafe package. You're really, really helping us out here. So that was interesting to learn that really Docker was really kind of abusing and really, really pushing the limits of what Go could do. Jesse just laughs. So anyway, let's come back up. Let's go back up a level. Let's talk about infra. So I wrote this book about infrastructure, and it's cloud native, and if you want to go read it, it's okay. But we're going to talk about this infrastructure layer because I spend a lot of time here, and it's really important to learn. We got to kind of learn these pieces, and then we kind of glue them all together at the end. So bear with me here. We learned about how these tools like Terraform have managed the infrastructure layer-y bits, and how Go has had a huge impact in it. So who has used Terraform? I know I keep making you guys raise your hand. I'm so sorry. I have also used Terraform. So why do we use Terraform? Luxury. It makes our life easier. Terraform to me is the Escalade of software. It's got the heated seats and the power windows and the anti-lock brakes, and you put on cruise control and you're it's silent, it's nice, it feels good, you're cruising it with Terraform. And it kind of does that with infrastructure. And to make that evolution, going back to the highway analogy again, is really, really powerful because we're writing software for luxury, not for necessity, but for luxury. So what does Terraform do? It talks to all these clouds. And I love how every cloud provider has a cloud logo for their thing. And how does Terraform do that? Well, it has this really, really complex graphing library. I got into graphing a couple years ago, and I fell in love with graphing. And the only way I fell in love with graphing was because I was doing graphing in Go. So who here has written a graph before? And who here has written a graph without pointers before? Okay, not very much fun. Not as much fun as it could be with pointers. But the whole graphing algorithm for Terraform is how it reasons about all these resources and understands if there's cycles in your graph or what we're going to do. And that's really how this program works. So how does Terraform do it? If you go in the Terraform docs, this is beautiful. This is Go sneaking its little nose up into the Terraform docs and people not realizing it. What Terraform does is it does all this graphing, but it does it around these implementations of this interface. So this is low-level interface here. And imagine if you don't know what a Go interface is and you're reading this for the first time. The interface you must implement for providers is called resource provider. And there's a link there. We're going to click on it in a second. And as a user, you go, oh, Terraform's great. All I have to do is go in and satisfy this interface, and poof, I have a cloud provider. And if you go and you look in the Terraform code, you can go in, and there's a ton of comments here. But up on line 19, resource provider interface. So the graph completely abstracts itself away. It says, I don't care about what's going on underneath. I just care about this interface. And that is a Go-ism. That's idiomatic Go sneaking its way into a program and changing the way humans think about the program. My button keeps breaking. Let's try this again. Click. OK, so we live in a world where cloud providers are just implementations. And that's a Glacier pick to keep you guys looking at the screen and excited. So thank you, Go. You have, again, shaped the way that software is being architected, designed, and implemented based on your feature set. OK, bro, what about Kubernetes? So like I mentioned earlier, I work on Kubernetes. And this is sort of the next version of everything we've talked about. So we learned how Go helped us build containers. We've learned how Go has helped us completely manipulate and take ownership of our cloud in a really, really beautiful and powerful way with tools like Terraform. And then Kubernetes came along and said, we're gonna like take all these ideas and we're gonna like take them and run. So we're gonna be learning about how Go has impacted Kubernetes. That cloud interface though, this is the same type of pattern we saw in Terraform, but it's in Kubernetes. And we're doing the same thing. We only concern ourselves with the interface. We don't concern ourselves with the implementation. And as long as something happens to implement this interface, we can interact with it. And Kubernetes is littered with stuff like this. How much time do I have? OK. Got you. So those containers, though, I'll go fast. I didn't realize I was running out of time. So if you've ever SSH'd into a Kubernetes box before, it's pretty boring. Nothing's going on except we're just running a bunch of containers. And that makes Kubernetes. Again, only possible because of Docker. Those static binaries, though. So that was a control plane, the master part of Kubernetes. This is the workhorse. What is it? It's a static binary. How do we run it? Systemd. Why do we run it like that? Because it's easy, because Go has let us run it like that. Also, concurrency in Kubernetes is huge. This morning, I went to Kubernetes, and I wrote a GitHub search query just to see how many Go routines are just in the standard library there. 4,945 Go routines called. Those might get actually ran who knows how many times. So I think it's safe to say Kubernetes is taking full advantage of concurrency with our control loops. The Kubernetes community, though, this is great. Who here is in the Kubernetes Slack? Do you guys remember earlier this year when Brian Grant channeled all 22,000 of us and like Slack like slowed down for like an hour? 22,000 people all in a Slack channel because software that was written with Go, built on these other constructs like Docker and Kubernetes, existed. If it wasn't for Go, we wouldn't have had Docker, we wouldn't have had Terraform, therefore we would never have really gotten to Kubernetes, debatable. But thanks Go, because now we're bringing 22,000 people together in a Slack channel and working towards making the cloud a better place. So, thought experiment, what if Go didn't win the cloud? Well, for one, I wouldn't have a job. I would be out climbing mountains somewhere. For two, I would probably still be writing interpreted languages and dealing with environments and my code not working on your machine and your code not working on my machine, or my server not working or your server not working. We would be building these monolithic ecosystems that solve the same problems that the Go standard library solves for us. We would be writing code that would like keep us from breaking things, or writing our own error handling subsystem to go in our program. And we've done this, and we did this for the past 5 years, but we don't have to do that anymore because of Go. We wouldn't have games that have fundamentally shifted the way our children are thinking about games by basing their games on where they geographically are located if it wasn't for Go and it wasn't for Kubernetes. So the cloud would be a lot harder than it is today, and it might not be as successful as it is today. So this is my little last bit here, I promise. So what are the lessons here? The cloud is changing the world, which means Go implicitly is changing the world. Spider-Man, because we're at GothamGo, with great power comes great responsibility. And as a community, we really need to keep our shit together, because we, more than any other programming language, are shaping the future and our children's futures with what we're writing. Also, everyone here who's writing Go blogs, people are reading them. We're changing things. The world is different because of us. Pat yourself on the back. We really helped make this what it is today, and we're all doing a great job. So keep up the good work. Thank you.
Thank you so much, Kris.